Here I have an experiment trying to increase the ear size of a dog population. The original mean of the population was 7 inches with a standard deviation of 1 inch, and the blue graph here represents the original population. So this purple zone here is the population I was selecting from to breed, and I was choosing from the upper 10%, which gives me a z-score of 1.282, and using that z-score, I was able to use it to calculate what my x bar t would be, using the equation x bar t equals mean plus z-score times standard deviation, which for me equals 8.282. What the xt is, it's the truncation point, and basically that is where the beginning of anything above that will be part of the upper 10% of the population. So in this case, anything above the ear length of 8.282 inches is going to be the selected population to be bred. Since I was using the upper 10%, I was also able to figure out that I had an I value of 1.755. This was important because I could use it in the equation. This is important because I was able to use it in the equation to find my S value, which was just I times the standard deviation, and what my which gave me 1.755. What the S value is the selection differential, which is just going to be the difference from where the average, where the x bar of s is, so the average of the dog ear length that I selected for, which in this case it was 8.755. So the difference from x bar s to x bar of o, the original population, using the s value, you can then use that to find the R value. The R value can be used by multiplying the narrow sense heritability and the selection differential together, which for me gave me 1.176. The R value is the response to selection. The response to selection is the difference between the new mean of the new generation and the old mean of the old generation. And the new mean for me was 8.176. Assuming if I were to continue this experiment indefinitely, I hypothesized that the reason my response from selection would decrease is because at a certain point there's a maximum length that the dog's ear genes would express a dog's ear length to, and there's just no way to get it to maximum because the environment also plays an effect. So the environment might cause it to be shorter than another dog who is in a different environment.